You ever feel like you're just swimming in information, but you can't find a single real answer? Well, that's pretty much the defining challenge of our modern world. And the solution, or at least a big part of it, is something called data mining. So let's dive in and figure out how we find those little nuggets of knowledge in a giant sea of data. So here's our game plan. First, we'll talk about why we even need data mining, this idea of a data ocean. Then, we'll look at where it came from. After that, we'll break down the actual playbook for how it works step by step. We'll explore the two main jobs it can do, and finally, we'll take a peek at what's next for this amazing field. All right, first up, let's set the stage with the big problem that data mining was basically invented to solve. This quote just nails it, right? We have become unbelievably good at collecting data. I mean, mountains of it. But turning all that raw information into something actually useful, that's a completely different challenge. Without the right tools, it's all just, well, noise. And this data explosion is happening literally everywhere. Think about it. In business, every single time you click on a website or make a transaction, that's data. In science, you've got these enormous data sets from genomics or climate simulations. And then there's us in our everyday lives, just constantly creating data with social media, photos, and videos. There's just no way a human could analyze all of that manually. It's impossible. Now, you might think data mining is some brand new thing that just popped up, but really it's the next logical step in this quest for knowledge that we've been on for centuries. It's really cool when you look at how science itself has evolved. We started with just observing the world around us. Then we moved on to developing theories and models to explain what we saw. Then came computers, which let us simulate incredibly complex systems. And now, since about the 90s, we're in the age of data science, where the sheer amount of data we have is what drives new discoveries. And right alongside the evolution of science, our technology for actually storing all that data was evolving too. We went from basic data collection in the 60s to these really sophisticated databases. And you can see right there in the 1990s, when we got really good at storing massive amounts of data in these things called data warehouses, that's exactly when data mining popped up as a truly critical field. Okay, so we know why we need it. Now let's get into the how, because data mining isn't just pushing a button and getting an answer. It's a real, structured, disciplined process. See, data mining isn't just one thing. It's more like a supergroup, a powerful team-up of a bunch of different fields. And that makes total sense, right? You need the brainpower of statistics and machine learning to find the patterns. You need the muscle of database technology just to manage all that data. And you absolutely need visualization to make sense of what you find. The formal, kind of academic name for this whole shebang is Knowledge Discovery in Databases, or KDD for short. You might also hear about something called CRISP-DM in the industry, but honestly, they both boil down to the same core idea. Finding insights is a systematic journey, not a single magic trick. And this KDD process is our playbook. It all starts with the most important step, knowing what question you're even trying to answer. From there, you gather the right data, and then you clean it up. And trust me, this step can take up most of your time. After that, you simplify it, pick the right tool for the job, run the analysis, and then, and this is key, you have to actually interpret what you found to see if it's real knowledge or just more noise. Okay, so we've got the playbook, but if you remember, one of those steps was to choose the mining task. So what are our options? Well, it really boils down to two main missions: trying to predict the future or trying to describe the present. The two big buckets here are predictive and descriptive tasks. Think of it this way. Predictive is like being a fortune teller. You use data from the past to make a good guess about the future. Descriptive is more like being a detective. You're sifting through the evidence to find interesting hidden patterns. The techie terms are supervised learning for predictive because you're guiding the process with labeled examples, and unsupervised learning for descriptive, where you're just letting the data itself show you the way. A classic predictive task is called classification. Basically, your goal is to put something into a specific box. Is this email spam or not spam? Is this transaction fraudulent or legitimate? Another type, called regression, is really similar, but instead of predicting a category, you're predicting a number, like the price of a stock or tomorrow's temperature. Now, on the descriptive side, a fantastic example is cluster analysis. This is pure, unsupervised work. You don't start with any labels. The algorithm's whole job is to look at the data and find natural groups on its own, like finding different segments of your customers based on what they buy. Another famous descriptive task is finding hidden connections, like the classic story of a store finding out that people who buy diapers also tend to buy beer. And here's a great way to visualize what clustering does. You start with what looks like just a random mess of dots. The algorithm goes in, finds the natural groupings, and sorts them. Everything inside one of those colored circles is really similar to everything else in that circle, but really different from the dots in the other circles. It finds the hidden structure for you. It's pretty amazing. So we've seen how powerful data mining is, but it's not a magic wand, and it's definitely not without its challenges. Let's wrap things up by looking at the road ahead. Researchers are always pushing the limits here. They're trying to figure out how to analyze really complex stuff like real-time data streams or social media networks. They're working to make algorithms faster so they can handle these mind-bogglingly huge data sets. And so importantly, they're tackling the huge ethical and technical challenges of making sure our data stays secure and our privacy is protected. The big takeaway here is that data mining is so much more than just technology. It's a whole new lens for looking at the world, and it leaves us with this incredible question. As our universe of data just keeps expanding every single second, what new knowledge, what amazing discoveries are still out there just hiding in plain sight, waiting for someone to ask the right question?